Alright, in this video we're going to do an example of solving a trig equation with a coefficient in the argument. And all that means is basically inside the parentheses, in front of the variable, notice we have different coefficients, not just a single theta or just a single x. And you have to be a little careful on these. We're going to find solutions that fall in the interval 0 to 2 pi. But we'll talk about that here in a second. So the first thing, we've got cosine squared of 2 theta equals 1/4. I'm going to rewrite that as cosine of 2 theta all being squared equals 1/4. Well, to get rid of the square, I'm going to square root both sides. And recall, when you take a square root, you've got to stick a positive and a negative on one side or the other. So on the left side, we'll be left with cosine of 2 theta equals positive, negative. Well, if you take the square root of 1, we get 1. If we take the square root of 4, we simply get 2. So I'm trying to figure out where cosine of 2 theta equals positive or negative 1/2. What I usually do on these is I make a little substitution. Okay, I'm going to let, say, we'll call it y. Let's let y equal 2 theta. So really now I'm trying to solve, well, cosine of y equals positive and negative 1/2. Okay, so why did I do that? Well, the idea is really sort of your interval has changed, because originally we wanted theta to be in the interval 0 to 2 pi. Okay, that was the original requirement. We said we want theta to be in 0 to 2 pi. Well, that means that 2 theta would have to be in, well, if you double this, 2 theta would be in the interval 0 to 4 pi. But 2 theta, we said that's the same thing as y. So really what we're doing is we're finding all solutions to cosine y equals positive 1/2 or negative 1/2 now in the interval 0 to 4 pi. Once we get these solutions, we'll sort of backtrack to get back to our solutions for theta. Okay, so that means we have to figure out where cosine y equals either positive 1/2 or cosine y equals negative 1/2. Well, cosine of y equals positive 1/2 at the angle, let's see, I think pi over 3 would be a place where that would happen. Also at 5 pi over 3 would be another place where that happens. But that would just be if we sort of make, if we just think about the interval 0 to 2 pi, we've sort of only went around the unit circle once. Well, since it's 0 to 4 pi, we can make 2 trips around the circle. So what I can do to each one of these is I could simply add 2 pi to get another solution. So pi over 3 plus 2 pi would be another solution. 5 pi over 3 plus 2 pi would also be another solution. And if we get common denominators, clean this up a little bit, I could multiply top and bottom by 3. That would give 6 pi over 3 plus 1 pi. We would get 7 pi over 3. And for our other one, if we multiply top and bottom by 3 to get common denominators, we would get 6 pi over 3 plus 5 pi. That would give us 11 pi over 3. Okay, so we're not done yet, but we've kind of got 4 solutions that we're going to use to help us get the solutions to the original equation. Well, also we have to figure out where cosine y equals negative 1/2. Well, that's going to happen at the angle, let's see, so pi over 3 is one of our solutions. That would happen at 2 pi over 3. Cosine of 2 pi over 3 would be negative 1/2. Also, cosine of 4 pi over 3 would equal negative 1/2. But now we can do the same thing. We can add 2 pi to each of these. So I'm going to add 2 pi to each of these. And again, if we get common denominators, you could multiply top and bottom by 3. That would give 6 pi over 3. So we would get 8 pi over 3. And likewise, if we add 6 pi over 3 to 4 pi over 3, we'll get 10 pi over 3. Okay, so now we've got these 4 solutions, these extra 4 solutions. So again, we want theta to be in the interval 0 to 2 pi. Definitely all of these answers are not in 0 to 2 pi, they're in 0 to 4 pi. But now I'm just going to kind of go back. So we said y, again, that was the same thing as our 2 theta. So y is the same thing as 2 theta. But we said solutions for y, we said y can either equal all of these numbers. It can equal pi over 3, y could equal 5 pi over 3, so equivalently 2 pi could equal 5 pi over 3. Likewise, if 2 theta equals 7 pi over 3, that'll be another solution. If we can let 2 theta equal 11 pi over 3, that'll be another solution. Got a lot of solutions here. If 2 theta equals 2 pi over 3, if we can figure out where 2 theta equals 4 pi over 3. So I'm just taking 2 theta and setting it equal to all of these values. So we'll get 2 theta equals 8 pi over 3. Last but not least, we'll get 2 theta equals 10 pi over 3. Okay, so now we've got a whole bunch of solutions, and what we're going to do now, again, we're trying to solve for theta. I'm just going to multiply each side by 1/2. So if we multiply, say the first both sides by 1/2, we'll simply be left with theta on the left, and if we multiply by 1/2, we'll get pi over 3 times 1/2, which is going to give us pi over 6. That's going to be one of our solutions. And now I just have to do this for just simply every value. So if we multiply by 1/2, we'll get 5 pi over 6. If we multiply by 1/2, again we'll get theta equals 7 pi over 6. If we multiply by 1/2, we'll get 11 pi over 6. If we multiply by 1/2, we would get 2 pi over 6. Or we can just reduce that to pi over 3. If we multiply 4 pi over 3 by 1/2, we would get 4 pi over 6, or equivalently, that would reduce to just simply 2 pi over 3. Let's see, getting a little closer, 8 pi over 3, if we multiply both sides by 1/2, we'll get 8 pi over 6, again, which would simply reduce to 4 pi over 3. Last but not least, we're having fun. Multiply both sides by 1/2, and we'll get 5 pi over 3 after simplifying. So notice all of these solutions. Notice all of these solutions for theta. They all do fall in the interval 0 to 2 pi, just like we wanted. So again, typically what I do in these types of problems, just try to eventually get it down to just cosine or sine or whatever your trig function is. I replace, again, if there's 2 theta, 3 theta, 80 theta, I would replace it, and I have to make sort of the corresponding adjustment to the interval, because now I've got to find sort of solutions in a different interval. I think about solutions in that new interval, so that's what we were doing here at the very beginning, thinking about those solutions in that interval 0 to 4 pi. But then I just go back and, sort of resubstitute back in that y was equal to 2 theta, set that equal to all the solutions I found, and then simply solve for theta, in this case by dividing by 2.